welcome to Main and 5W channel. In this session, we will be covering some of the big data and AI algorithms. So to brief, we are not going to get into understanding what is big data, what is AI in this session. We're generally going to jump into some of the perspective views of algorithms. For people who are very new to big data, it talks about the 4 V's. Whenever the data is of large volume, when the data arriving at a faster rate, which you cannot predict, like velocity. And then there is variety of data coming from structured, unstructured, from text file. It could be coming from a machine, it coming from IoT, blah, blah, blah. And then you have a concept where you have the veracity or the value of this data. So that's a big data. We all know what is AI, machine learning, deep learning. We don't want to repeat those things. It's a new era of where you can do data science with your data. So big data is one of the early days where you started moving from database to data warehouse to big data, and now you're talking about data science, where a lot of these machine learning algorithms are applied. Now, this algorithm as a service, which we covered in the other session, is very important because end of the day, what you're doing is writing a logic. That's the job of software people, right? So we're just going to cover some of the key areas where we have seen the algorithms in place. So the first area what I wanted to cover is fundamentally the machine learning in the Hadoop. Now first let me brief about what is Hadoop. Now when we implemented this big data maybe 5 years back, the way we used to do it is by using an algorithm. We used to use an algorithm called MapReduce, Hadoop. So these are technologies which you can use to implement big data solutions. The key thing is when large volume of data is arriving into from a client side or from the user in a streaming way, right? So you need to really look at how you can take this data and process this data very fast, and then you can store it back to your database, right? So Hadoop was, you had HDFS, the Hadoop file systems, and then when large volume of data, how do you really apply and see which particular data is important? You used to use a MapReduce algorithms, and then you had a lot of ways to store this data in relational, which is called Hive, and then there was machine learning to be run on this particular Hadoop, which is Mahot. So there's so many areas which came up. So we're going to cover like when there is a bridge between like Hadoop data available, data is coming through the big data, then how do you do some machine learning? What are some of the algorithms? So these are some of the algorithms which are there. We call it as a collaborative filtering, classification, clustering. So we need to understand what you do in typical data is large volume of data is you need to filter the data. You need to classify the data. You might want to cluster the data. So for that, there are various algorithms. We're not going to cover up all these things. We'll have for each algorithm, it needs maybe half a day to understand, but briefly, these are different types of mode of algorithm which you can run in Mahot in Hadoop. For example, if you're telling classification, you will do logistic regression. So they're all statistics thing, or it could be random forest. It could be hidden Markov models, multi-layer perceptron, okay, which is basically can be used for classification of the data. So when the data comes, how do you classify? Similarly, if you want to filter the data, you can use collaborative filtering. It could be user-based collaborative filtering, item-based collaborative filtering, blah, blah, blah. Similarly, for clustering, we can use k-means clustering. So the idea is not to teach you, but like in a typical data availability, how do you really do filtering, classification, clustering? You have a lot of default algorithms built in. And some of the similarity measurement we do, these are all some of the examples like Pearson correlation similarity, Euclidean distance similarity, cosine measurement similarity, Spearman correlation similarity, Tanimoto coefficient similarity. I think we saw about this in the recent session. So what are these things? They're all a way by which you can do similarity measurements. Now, why are these important? When you take a practical example, so all this looks very simple. Like if you want to create an event and then there are a lot of customers trying to come in and trying to log in into the event. You want to find out which of a set of customers are very related to each other who are trying to come into this particular thing. So if you want to get into all these things, one is you are a code developer who want to write all the algorithms, but people have already made some kind of investments or thinking into it. So you just can make use of these algorithms and formulas in your code, maybe in Python or Java, to really run this fast. So for example, the Pearson correlation similarity formula is here, like, I think we covered this in the last session. There are a lot of data available, which you can see, like 101, 5.0, like that, the data is available. And there are different user and different items. And then you can see there is some missing data. So you can see that there's some kind of correlation with user 1 you can do in this particular data. For this user, for this item, what is the correlation with the user? So like that, you will be able to use this formula to build up things. Now you might find that like these formulas are pretty difficult, but they are not. So as you start working on these in detail, I think it could be very simple for you to understand how this data are correlated. Like for clustering, let's take this example. There are different cars, right? Imagine how a human being works. He can see a car and tell this is a Hyundai car. Okay, this is a BMW car. How do you really, how did you identify that this is this car? Okay, if you start thinking it, then you're thinking an algorithm, which is actually built into the human being, right? Basically, he has seen the car, he's seen the shape of the car, blah, 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 and then he quickly makes a decision. Now, if you have to train this into a system, it's not going to be easy because most of the cars have the similar shapes. Okay, and if a machine has to read it and differentiate it, it really becomes very difficult, right? So in a clustering is a collection involving three things: an algorithm, method to use to group the things together, a notion of similarity and dissimilarity, which is the second one. Okay, like for example, if you take an example of a book, an algorithm is a method used to group the books together. A notion of similarity could be that which books belong in an existing stack which should start a new one. A stopping condition, like in a library, it might be a point beyond which books cannot be stacked anymore, blah, blah, blah. Okay. Now then on the clustering, you can tell cluster 1, cluster 2, cluster 0. You put it on a plane and then you start really mapping it. Similarly, you have an example of a vectorization example here. You have a weight, you have a color, you have a size. Okay. And then you're telling a different conditions like small round green, the weight is 0.11, large oval red, you have a weight of 0.23, and then for a color, then for a size, and then there is a vector which has been mapped for that. This is another example. So mathematically, what we have been learning in our K-12 or in a graduate degree or something, you need to relate it to like solving a problem for an end customer. So that's how it looks very simple. So for example, here is a classical example. You can use the SVM to recognize the Toyota Camry. Okay. So symbol as something like bull's head, big black portion in front of car, and rule 3. You apply different rules and then be able to pick from this particular list of things what is the Toyota Camry. Okay. So there could be a lot of positive signs which it shows, okay, by using the support vector mission, and finally it is able to recognize that it's a Toyota Camry. So it's not an easy thing, right, as we see. So when to use big data for classification? When the size could be maybe less than 100,000. Okay, traditional non-Mahout approaches should work very well. Mahout may not even be slower for training. Okay, so when it is from 10,000 to 1 million, you can look at Mahout, this is a good choice. When 1 million to 10 million is an excellent choice. Greater than 10 excels where others will fail. So based on the system size, you need to categorize with a small size. Why should you look at something like a Mahout or a ML for your big data systems? So the key terminology which you use for a thing is a model, training data, test data, training example, feature, variable, record, field, predictor variable, and target variable. These are a list of terminology we use to really classify the different type of data. So if you really look at it from how will you relate this AI, ML, and big data analytics, that's a very interesting topic because AI comes in the domain of machine learning, deep learning. Different types of learnings are there: supervised, reinforcement, unsupervised, which we saw, and then there is a big data analytics. So we can actually see that there has been a lot of implementation last 4-5 years in AI, but big data was there for maybe a longer period of time. So the future of AI, this comes is basically on how you use. This slide is from Columbia University. You can see that it's a nicely put slide. I thought I'll use it for this session. Basically, what this slide is talking about is a very important part of understanding most of the existing AI is only a key fundamental component. Now let's look at the slide in detail. So what is the slide is trying to communicate in my own words is, if you really see your way the brain is functioning, right? The first thing you do is you remember a set of facts. Okay, that's your memory, right? Number one, as simple as that. So this memory could be called as a graph database or distributed native database. Okay, it's a neural network database, whatever you call, where you have information which is being really processed. The second is basically the representation, which is pretty complex, and the sensors, which is basically the way your nervous system is really working, right? So that's the graph analytics like network analytics, flow predictions, which comes in, and also the advanced visualization like dynamic and interactive big data visualization, right? Recognition is basically machine learning and deep learning, which uses autonomous imperfect learning. And then you have perceptions, like, which is very, very difficult to really automate, right? Machine cognition like robot cognition tools, feeling, human interactions. And there is a comprehension strategy like machine reasoning, the Bayesian network game theory. Now, the reason is like when scientists, including all universities, which I have really done a research, is basically what they're trying to do is if you have to mimic the brain, it's easy to mimic something which is pretty straightforward, which is pretty linear in nature. But if there are perceptions, if there are intelligence, if there are changes, if there is very dynamism in your thinking, then it becomes very difficult for something like an AI to automate. Okay. So the evolution of AI is always been that there is a kind of a layering kind of concepts like no sensor layer, feature layer, concept layer, semantic layer, cognition. So the future is going to be really look at how we can automate all parts of the brain thinking. So that's a brief I wanted to cover, but in a nutshell, the idea of this session was we will be covering each of these algorithms in detail. So I'm trying to really bridge the gap between whenever you develop an applications, you call it like you're trying to do something with big data, something with AI, ML. So that is a bit of analytical visualization, all kind of applications. So you use these algorithms, which is coming from AI, machine learning, big data. If you are using an open source Hadoop, you use a Mahout algorithms, and based on your data size, you start really working on it, right? So we'll cover each of these things in detail in further session, and thanks for watching.